Hello everyone, welcome back to Nated Engineering. Today we are looking at shock load, which is the second way in which a force can be applied to an object. What happens when you are jumping up and down on a weight scale? You will notice that on the gauge, even if let's say your weight is equals to 50 Newton, on the gauge, you will be able to record a weight that is way higher than 50 Newton as you are jumping up and down. You're jumping up, and as you are coming to contact with the weight scale, the scale will record a weight that is way greater than your actual weight, which will be 50 Newton. You might record a weight of 80 Newton just by jumping up and down. And that is what we call shock load. Shock load is defined as is a load that will fall through a distance before it hits the component. This load falling will cause the force in the member, which is much more than the load applied. Hence, I'm saying you will be able to record a force that is way greater than your original or your actual weight. As the object, which is you, come to contact with the scale, in this case, the recorded weight will be greater than the actual weight. Therefore, the force recorded or the force that is applied on the scale will always be greater than your actual weight. This you must remember when you are dealing with shock load, that the force, when you are doing calculations, the force will always be, it's supposed to be the other way around. The force will always be greater than the weight of the object that we are dealing with. It's supposed to be like this. So instead of jumping up and down, if you can make one jump and come back to the scale, you will notice that the scale will oscillate, meaning it will go and record a force that is higher than your actual weight as you land to the weight scale, but it will then come back to record the actual scale, the actual weight, which will be 50 Newton. And from that example, we can see that the strain caused by a shock load will be much greater than the one by a gradually applied load of the same magnitude. Because as you land to the scale, the weight recorded will be much greater than what your actual weight is, which will be shock load. And then after that, the scale will come back to record the original weight, which will be now gradually applied load, where we have the force being equal to the weight. Let's look at this scenario now, where we are having a road and we are having an object above the bottom of this road with a height of h. At a height of h, we let this object to fall and hit the rod, the bottom of the rod. At first, as it is coming into contact with the rod, the kind of force that will be exerted on the rod will be the shock load. Therefore, the shock load will cause this effect, which is the total change in length. This will be the change in length. H is the distance at which the object is falling before it comes to contact with the rod. Remember, as it comes to contact with the rod, because it was falling, it will cause what? Shock load, meaning it will be causing a force that is greater than its actual weight. And then the shock load will have this effect. And then gradually it will come back as it did on the scale when we said it will oscillate. If you jump up and down on the scale, the gauge will record a force that is higher than your actual weight and then come back. This is exactly what's going to happen here. It will go down and then it will come back, where we are now affected by the force, the actual force of the object, meaning the force it's now equals to the weight. Here, the force exerted was greater than the weight. So this will be our change in length due to the shock. This will be our change in length due to the gradually applied. So if they ask you these questions, this will be the final change in length, and this will be the instantaneous change in length, because this was the change in length that happened immediately as the object came into contact with the rod. It caused the rod to come to this position, whereas after, due to gradually applied, it went back to this position. So this is the final change in length. So don't confuse those two. Taking this position as the reference, we will have to calculate for the potential energy of the object at this position. EP at the top will be equals to the strain energy at the bottom. We know that potential energy is given by mgh. Mg will give us the weight, which will be the weight of the object. The height will be the height from this point to this point, which will be h plus the change in length. And then our potential energy will now be W in bracket h plus change in length, or total change in length, which will be equals to the strain energy at the bottom. We know strain energy, it's half F x total. And this will be the formula that you are working with whenever you are told about shock load. To calculate for the change in length, which will be xtg, we know change in length is the force length divided by E times the area. Here, the force is equals to the weight. Therefore, we can put the weight here instead of putting F. You can say it's WLE divided by EA. But to calculate for the total change in length, which will be here, there we are going to use the force length EA. Remember that the force, it's always greater than the weight. And that is all that we need to know about shock load. I will see you on the next lesson.